I
Or
think
doesn't
I've
yet?
started.
Yes, sir. Now it's come up.
Cool. So, right. So basically, we are working on this game since the last session, and we'll complete this game in today's session. We'll look at how to deploy it, how to build it, and how to deploy it to the web, and also how to share it as an exe in PC or in other formats on Mac and Linux, those things. So this is where we were the last time. This is where we left our game. And what we have built till now is basically a player which is moving in the environment using the horizontal and vertical axis keys, which are basically forward, backward, left, right, WASD, or up, down, left, and right arrow keys. We have some in objects that we have created, which are supposed to be our collectibles. And this is what we'll be completing next, is when we touch these objects or go through these objects, the player should be able to pick those objects up, or those objects should not be in the scene anymore. That is what this game is about, and you have to complete the game by picking up all the objects. So, uh, before we do that, like one thing that was remaining in adding in our scene was basically a boundary wall that we wanted to add. So, going back to our scene, this is the scene that we have right now. Let's add walls to it. So we'll create one 3D object cube. We'll center it out. And then basically scale it. So we know the length is 20, so just make it 20. And we can just push this to one of the sides. This will be around -10. If we have a closer look, you can see that it feels like a wall. And renaming it to left wall, this is the wall on the left side. Similarly, we can just, like we learned last time, whenever we click on an object and click Control D, it duplicates. So we duplicated this, and then changing this to 10 would basically make the right wall. Similarly, we can duplicate it once more. So there are two ways now we can do it. Either change the scale like this to 20 and 1, 0, 10. So this is one way. The other way was that we could have just rotated it, and it would have had the same result. So up wall and duplicate it, give it -10, and the final down wall. This is what we have in our scene now, and looks okay. And if we play, we'll see that we will not fall off from the ground. And as you can see, there's some physics effect that's happening when I go in speed and hit it. There's a bit of a bounce this when I collide with the ball. So this is like you can play around with this effect. You can make it more bouncy. You can make it stiff depending upon how you want to keep your collisions. with the walls, with the boundaries. It depends on you how you want to uh, change that. And we look at how differently we can do this at a later stage. But right now, this is good for us. This is what this will work for our purposes. And if we want, we can increase the size of each of them by a bit, like bring them up a bit, 0.5 above from the ground. And to keep the scene proper, we'll create another empty object, call it walls, center it out, and keep all the walls inside this. So fine and done. So finally, we are done with all the things that we wanted in our environment according to the setup that we have created. We have collectibles, we have the player, we have the ground, and we have the walls. So now, coming to basically how do we actually pick up the collectibles, right? So we have the player, and you see that there's a uh, script, there's a component attached to the player known as the sphere collider. You can see here, right? And then if we look at the collectible, we can see another uh, component attached to it here known as the box collider. So let's actually look at what it does, what it is, how we'll basically use this and how this works. So if I click on my player and if I go a bit more here and I turn off my mesh renderer, I can see that there's this green outer covering that I see. If I click on edit collider, so there's this ball shaped wire that I can see that is basically this is what I'm calling the collider. And this is something that is encapsulating the sphere that I have. It has a component, it has a center of its own, it has a radius of its own. Apart from the mesh that we had, this is something that is covering the ball. So by default, it is the exact same size as the ball that as the renderer that we have or as the ball that we have with center at 0 and radius which is same as the like the size scale uh, of the sphere that we have. Similarly, if we look at one of the collectibles and we turn off the mesh renderer, we can see that it is we have a cube outline, and here also we have uh, a similar center and a size of its own. So this is basically what will be is used to basically detect and create physics collisions. So how do we actually check this in the environment in our code? So basically, we'll need to write some code in our player controller. So we already have a script called player controller, right? So we'll write some script here, which will basically correspond to checking the collisions with this specific collectible. This specific collectible means all the collectibles that are in the environment, and it will not check all collisions, basically not check colliding with the ground that it is being doing when it is rolling, or not check collisions with the wall. So how do we do those two things? One is we want to check collisions. The second is that we want to check specific collisions. We want to check collisions only when it collides with these objects, not with anything else like the ground or the wall. So how do we do that? Let's go to our uh, player controller, opening it up. So first we'll basically create a variable and we'll create a private variable and we'll call it count. So this variable is going to be a variable which is going to store all the number of count of the all the collectibles that the player had already collected. So when we start, this value should start with a value of 0. And somewhere basically now that it has started, now whenever there's a collision, whenever there's some form of uh, uh, collection done by the player, this variable count should increase its value from 1 to some other value, right? So let's see how we can do that. So now we'll basically use a function. Let me see if I can show you the documentation, and that would be more helpful. So basically, this is how you can also refer to the documentation of Unity. All the components that you see here, if you want to refer to specific documentation regarding any of these components, there's a question mark here, which basically opens the reference of this specific uh, component in the documentation that Unity provides. So we want to look at this reference, and this reference is basically telling us what all these things mean, what all the components variables that are available to us in the component actually mean. And if you see, we saw that there's a button called is trigger. So is trigger, if enabled, this collider is used for triggering event and then ignores the physics engine. Then there's a material which refers to the reference of the physics material can be given here. Then we have a center, we have a radius. So basically this page is telling us about the details of the sphere collider component, but we want to see what we can do with it in scripting. So we'll click here, which says switch to scripting. So we'll click here, and this will basically open for us all the scripts or all the functions that you can basically use that are related with the sphere collider. So we see that these are some of the methods that are there that are attached with it, right? And basically what we want is here. So what we want to use is on trigger enter, this function. So when a game object collides with another game objects, Unity calls on trigger enter. So this is what we want to use. So let's see how this is used. On trigger enter, let's open it up. So they have given us an example. They have given us how to use it. They have created an on trigger function, and they have basically just created a function where whenever something is colliding, the speed is increasing, or speed is decreasing. Speed is multiplied by -1. So after a collision, speed is changing direction, basically, not increasing or decreasing, just changing direction because it is being multiplied by -1. Right? So we now know that this is how we have to use the function. We basically write on trigger enter, and some collider will be passed here. So this will be the collider that we have, the other collider. Basically, the object that this object collides with. The game object on which this is applied is the current game object. The other is the object that this game object collides with. And if you want to reference that object inside this script, we can reference it through by using the keyword other or whatever basically we name here, not necessarily to name it other, but this is the convention that is generally used and we use that. So going back to our script, we want to basically now use the on trigger enter function, and got it, right? So now we get the on trigger enter function. And what do we want to do in this? In this, what we want to do is basically check if the other collider is basically the uh, collider that we have, uh, the collectible, not any other collider. So how do we do that? So let's see if there's any function here to which we can use. So in the methods in the collider, there's this function called as compare tag. So this is something that we use. So checks the game object's tag against the defined tag. Right? So let's use this function. How do we use this function? We basically just pass a string, and if that string matches, then it works. So this is how we use this function. So void on trigger enter. If other.compare tag is player, then destroy the other game object. So this is something that we also want to do. If we want to check if the other.compare tag is collectible or pickup, not player, because we are writing the script on player. We'll check up if the other compare tag is pickup or collectible or whatever we want to name it. We'll name it pickup, and then we'll destroy the game object. There's other ways of doing this. We can either destroy it or disable it, depending upon what we want to do. We'll look at both ways of doing it. Right. So let's go here and write this if other dot game object dot compare tag, and we'll write some tag here. We'll write pickup. Then what do we want to do? We'll destroy other.game object. Let's try this one first. Destroy other.game object. Great. So now that we have written this tag here, pickup, but we have not really made it anywhere. How does the game know that? How does our script, or how does this script check this tag? Or how will we know that this collectible is actually that tag pickup? So basically, if you see here, there are two things that are here: tag and layer. Layers are also we can use for some separate things, but right now we are using tags. So tags are basically, we already have some tags here like respawn, finish, editor only, main, camera, player. These are tags that are predefined. So we want to add a new tag which we just wrote pickup, and it is important to write it as you have written here. Like PIC in this, P is capital and U is capital in pickup. So I'll just copy it from here and add it over here. Save. So now if I go back here, you see it's not added yet, but I can add it. It's not added yet, but I can add it. And then I'll just change it to pickup. And basically, since this was a prefab, it has not applied to everyone, applied to all. So I just apply all, and now all my collectibles are mentioned as pickups. So now let's see if it actually works, or is there some problem, right? So moving on and going, we are touching it, but it's not working. So did we do something wrong? Let's check. Let's check what the collectible is. So right now what we are doing is basically we are using this as a trigger, but we have not actually changed it to trigger. We are still keeping it as a collider, so it's still acting as a physics object and not as a trigger object. So basically it's colliding and creating bouncing effect. It's actually measuring the collision intensity and things like that. So once we make this trigger and then again apply to all, just check a few. All of them are is trigger now. The is trigger has been activated. So basically now that function where we were basically doing on trigger enter. So this thing should be working. So now it's working. Now we see that basically when it touches, it destroys. Like you see, check here in the hierarchy. Whenever I'm going through a collectible, it is destroying that. So this was one way that I can do it, and this is working fine, right? But what is another way that I can do the same, get the same effect? this also is fine. This basically calls a destroy uh, mm, call basically for destroying this object. But we can also just instead of doing this, what we can do is basically other dot game object dot set active false. So what this does is basically set active is a function which can be used to any game object, and it activates or deactivates the game object depending upon what we pass here. So if we pass false, it will deactivate. If we pass true, it will activate. So let's check if this is working for us now. And what does activating and deactivating mean? We have already seen this now for a lot of different things. Activating is basically when this is ticked on. Deactivating is when this is ticked off. So now if we move around, so we see that it's disappearing from the scene, but it's still here. It's just deactivated, right? So this is one way of doing it. Both the ways are correct. Both the ways have their own pros and cons in respect to when we create larger games. But what we are doing right now doesn't really warrant that level of scrutiny. So this is how we add this functionality. And now what we want to do next is basically when you pick this one up, we basically increase the value of count. So we'll do count equals to count plus one. So obviously there's different ways of writing this line as well. Count plus count plus equals to one. All those things work here as well. Whatever you've learned in any other programming languages, same thing applies here as well. Similar things, not same things, but yeah, similar concepts apply here as well. So now we are done with this. So what do we want to do next? Now we have this count variable stored in a private uh, variable, but in a generally when we want when we're creating a game, we would want the user to be able to see his score basically. So this is the score that we are generating in this game, right? The amount of collectibles that the player is collecting. So we have a total of 10 collectibles, and we want to show the user that he is collecting those collectibles, and basically whenever he collects it, uh, we want to show it on the screen, the number increasing, something like that, right? So let's look at a bit of UI, how we can do that, how we can show it on the screen and things like that. Just give me a second. Okay, so now what we'll do is basically add a UI element, some text basically. So in your new systems, what you will see is basically you'll see this that text mesh pro is by default coming as your default. Whenever there's a text written in the environment, text mesh pro will be your default option. But there's a legacy system which was not based on text mesh pro, so this is also there for you to use. But text mesh pro is mostly used as a default option right now, so this is what we'll be using. So we want to add a text to the scene. We use this text mesh pro. And you see that when we add this to the screen, there are some other things that come with it. A canvas comes, an event system comes. So event system is something that handles the input and all the things for the canvas. And this is generally very much required when we are using it when we are using any form of UI in Unity. So you learn more of this eventually, but there's nothing you want to do with this. There's nothing that has to be done. Whenever you add a canvas, this will just show up. So you don't have to change anything, add anything, do anything. This just works as is. And then there's a canvas that is added. If I click on canvas, this is what has been added to my scene. I can basically now change if I want to see it in a 2D view. I can click on 2D, and this is how it's being shown to me right now. If I go here, I see that that text that I added is added to the right bottom corner here for some reason, right? Generally, this is added to the center. I don't know why it's added here, but anyway. So what we want to do is basically bring it. Let's say we want to keep it somewhere here on the left top corner. So what we'll do is basically go to this text and see the things that are available to us in the inspector of the text. So initially you see that there's a transform here as well, but it is a bit different from the transforms that are available to us in other game objects. So this is something called as a rect transform. This has a bit more functionality than regular transforms that are available to us for other game objects. We like any other game object that you see, it has a transform. Canvas, the UI element has a rect transform. So basically this allows you to set anchors and pivots also along with position and width and height and all those things. So basically changing all these settings is basically what you're doing is in a way trying to set it to a specific location or a specific respective relative location inside your canvas. So next we have a canvas renderer and then the actual text. So like this is where you basically place your placeholder text. This can be empty because we'll be changing it through script, but just as a placeholder, let's make it count. We'll write count here just as a placeholder. It doesn't really matter what we write here. This is just for basically, our convenience, because if we add more text in the screen around here or any other elements, different kinds of elements, then we want to know that, yeah, we've something, what is what when we want to see it in the scene here itself, right? That, and then there are options to basically manipulate the font, size, wrapping, alignment, all those things are there, which are generally associated with text, and you can basically have a look and at what all you want to do. And that's it. That's the text that we have. So how do we basically change the position of this to the top left corner? One is basically you change the XY locations and drag it, drop it there. One way of doing that is basically going here and checking that, like, see that it says press shift for also set pivot, and pressing alt will also set position. So I'll click shift and I'll click alt, and then I'll click this place. This is where we want it. So I'll click this. So you see that it has changed the pivot. Pivot is basically this thing that you see, the I'll go in a deep. So sorry, this flowery thing that you see, this is basically setting the pivot. So I've set the pivot to the topmost left corner. What does pivot actually mean? So what pivot does is basically when depending upon different screen sizes that are changing, it calculates where to keep this text where to keep this specific element, and how do we calculate the position of this element from, which position do we start and calculate the position of this element from. So this 0000 is where we are starting to calculate the position of this element. So like right now you see it's 0000, but if I click on this and start taking it away, you'll see that the position is changing. So I want to basically give some padding on the top anyway. So I'll make it 20 and -20 in the y direction. And this is how it looks now. So it looks good to me, basically just as a count variable, nothing else. And let's see now, how do we actually change this text while we are writing when through our script, whenever basically we are picking up an object, we want to change the text here, right? So one more thing that we want to go through is, before this, whenever we are creating any kind of UI element, it has to come inside a canvas. So let's see what a canvas holds. Canvas is basically, again, canvas also has a rect transform, but doesn't really matter in case as long as you are in world screen space. So there are two ways: screen space overlay, screen space camera, and world space. So world space you will generally use to basically set up canvases inside your environment and not directly on your screen. So this screen space overlay basically doesn't take into account where you have kept the canvas in the environment, what is the width, what is the height, doesn't really matter. Whatever you basically keep inside this canvas, it will try to bring it to you the most at the most forward location. And similarly for screen space camera, this basically will overlay everything on a specific camera and not just your screen. But this two functionalities are similar. World space, which basically uh, converts this into a element inside your world, and basically you can then go inside your environment. Like let's say if you create a banner and you want to add some text on that banner, so that is where you will use world space. And world space is used a lot when we use something in VR or AR, when we want to add text inside elements inside the environment. Where let's say I'm creating in VR, if I'm creating a 3D first person based shooter game. Generally, when I create games on desktop or for mobile, I'll have all this information like number of bullets, number of enemies killed, enemies near you, mini map. All those things will be near on my screen, right? I'll have a focused screen to see what is going on in between, and then elements will be around that. But the same can't be done or is not very feasible to do when we are doing it in immersive VR, when we are basically wearing a headset. So it's not very feasible or not very practical to put all small elements around your eyes itself. So basically, that is when some strategic decisions are made, and you basically, let's say you want to keep number of bullets and kills. So you, whenever you make a 3D gun, you can keep something like text over that gun and write number of bullets and things like that. If you want to show a mini map, you can show it in watch, something like that. So basically, there's a design paradigm that shifts when you are moving from uh, basically desktop-based scenarios to AR or to VR. Different design principles come up, and this has a lot to do with how the user interacts with your game, or how the user experiences your game or simulation or environment that you've created. So keep understanding these things, or understanding the impact of these things is very important. So now there's one more option that we have here is basically this thing, target display. I can choose which display I want to display this specific canvas on. And basically I have, this is something that I want to draw your attention to right now, is something called as canvas scaler. So right now what we have is a constant pixel size. So basically this means is wherever I put my text or different UI elements on, that is where they'll remain. But if I want to change this scale with screen size or constant physical size, I can do that. If I scale with screen size, then it becomes a bit more flexible, and it will allow me to give it a reference uh, resolution, and then it will try to match whenever I change the screen size. It will try to match, like you see, it's trying to match the position, but it's changing the font and everything of the component. So based on how I do this, like references I match, whatever I do here, I'll try to match it here, and it is trying to match the width. If I try to match the height, then you see the height, like this thing is not changed. And I can basically make it somewhere in between, and then both those things will change, and you see both those things are changing. And basically, it will still be in the position that it is supposed to be. So this is it's kind of tricky to work with, and as you gain more experience with it, you can basically, depending upon your skills and how you want to set up your interface and various different factors, you'll come back to this canvas scaler and make changes to this. So now just going back to what we already have, uh, we have already set up our text, and now let's look at how we can basically change the text through script. So going back to the player controller itself. So this is the count that we want to display on that text. So before we do some of those things, we want to include some of the things from Unity namespaces. So you must have, if you've studied C++ or any other similar programming language before, then you know the concepts of namespaces. Namespaces are basically a collection of methods or collections of classes that have been predefined for us, right? So basically in Unity, we have some namespaces that are there, which we are already using like systems.collection. These are C# classes. Then we have a namespace Unity engine, and then there are other specific namespaces that we want to use inside Unity engine as well. So there's a namespace that we want to use, Unity engine.ui. I don't think we'll use it, but just in case. And then there's a namespace that we want to use, which is TextMesh Pro. So this is called as TM Pro. So these are the two things that we want to use. And now let's create a public variable that holds the text component that we have created. So this would be something called as TextMesh Pro UG UI, and let's call it count text. So this is the component that will hold our count text, and then we want to create a count text dot text equals. What do we want to write in this? We want to write count and then add number of count actual and then toString. So this is how we set this up. Right now our count is 0, and this is how we write it in the start function. And similarly, we'll update the same thing. Once the count is being updated, we'll do the same thing here as well. So let's just copy and paste. Let's see if this works. So back here, we didn't change the name of our text. So just for, although we won't have a lot of text in this, but just to keep the system proper, we create the player. In the player, we created count text, drag and drop the count text on it, and go to play mode. So now we see that count is 0. Let's see if when we start collecting, it's changing. Right, so we have a maximum of 10 collectibles in the environment. So basically that's the count that's showing up. So now a few things more that we can change here is basically generally it's not advisable to write the same line of code twice, right? So this is something that you must have read in best practices for coding. So if you have to write something multiple times, make it a function, right? So let's make a function for this specific line of code. We can call that function display text. So we'll make void display text and function, and we just want this specific line to be there for now. And we'll just call this function when we want to actually use that. Cool. So now what one more thing we can do is basically just a second. Yeah, so we can basically add one more text here, which we call as when like just when we collect all the objects, just an indication that the player has won. Let's just write you win and exclamation mark. Can increase the size of this. Let's say make it 60. Go to this, increase the size a bit, change it to top, Shift Alt top, not all the way top, so maybe minus 100 or 200. And back here, this is where UWin will show up, but we want this to show up only when the player has collected all the uh, all the collectibles. Before that, it can be deactivated. So let's deactivate it and let's write it in script of how we want to basically activate it. So similarly, again, I will make a public text mesh pro UGUI win text, and in my display text function, I can just write if count equal 10. Then basically win text dot game object dot set active. We just saw what this function does, equals to. Saving this, going back here, display. Let's see if this works now. We forgot to attach the reference, and basically that's all. Go back to player, drag and drop the win text. That's it. Then test once more. Okay, and I guess I'm not very good at playing this. Great. So now my game is complete basically. But like let's say I'm at this scene, and what do I want to do next? So I just want to add one more functionality in this to basically restart it. Like how if I want to play it in Unity, obviously I can just press this again and then restart it. But what if I'm in like the actual game and I want to restart it or just go back to the beginning and start again, right? So how do I do that? So for that, what I'll do is again, we'll go back to our canvas, we'll create something called a button, and we use a button whenever that button is pressed, we'll basically reload the game from the start. So go to the button, name it reload, and change the placeholder text to reload. This thing, Shift Alt, make it to the right, bring it below minus 50, maybe minus 100. Somewhere here is fine. Just minus 50, maybe. This looks good. So how do we basically add some functionality to the button? So if you see, like button also has a lot of different components attached to it. There's an image, there's a button, there's a child to it, which is a text. So those things are there, but right now all we want to keep note of is this basically on-click functionality. So we'll basically add some function here in this on-click, which will basically tell the button what to do when it is clicked on. So to basically attach something here, let's say on-click, we basically want to attach some game object here. So what is one game object that we are 100% sure will always be in a scene? Is something either the main camera or directional light, right? So I already have a script attached on my main camera. So this is with camera controller. So generally this is not a very good practice, but for right now, for just showing this, I'll basically add a function to the camera controller, and I'll call this function. I have to make this function public. I'll call this reload. That's all. And basically all I have to do is basically something called as scene manager. So I have a scene manager class in Unity, and in that scene manager, I have a function called as load scene. And the scene that I have right now is 0. So you see that it's showing up with a red line. If I click on this and click on this, it will show me to add Unity engine.scene management to my script. This namespace, I'll just click on this, it'll add that, and now it's working. So now what happens is, if I go back to this on my button, on the events that I have, what happens when I on click, I want to get the camera, and now I can check get whatever function the camera has. So in the camera controller, I created this reload script. So now my button is functional. All I have to do now is I've created an on-click event based on a script that was attached on the camera. On the camera, the script attached reload is basically doing what it is doing, is has a function attached inside it. It's basically calling a load scene function, and it is loading the scene number 0. I can also pass a string here, and basically that string is the name of the scene. But 0, where am I getting this 0 from? Is basically go to edit, sorry, not edit, file, build settings, and then if you remember, we were here in one of the few initial sessions, and basically we added this scene add open scenes whenever we do. So we get this number 0 here. So rollerball is our scene, and we know that this 0 is referring to this scene. So now everything is there, and let's play and see what happens. So now I start playing. Working, everything is working. If I just click on reload, so everything resets. Count is 0, player is in the center, all the collectibles are back, everything is reset. So this is how this reload button works. So similarly, I can create a quit button, which basically removes me from the game, closes the game, and all those things are done. So this is about creating the game. Our game is done, great. You can play, you can share with friends, all that. And let's see now how do we actually share it with friends, and how do we actually uh, show it in our portfolio? How do we add it to the web? So again, this is something where we go file, build settings. And in build settings, if you're on a Windows, Mac, or Linux, like I am on a Windows, so this is what will show up here, like target platform. Depending upon which system you are creating on, you will show that you will get this target platform. So I'm getting Windows. Architecture, I have 64 or 32-bit. I have some, these are options that you can look into on your own. There's a few options that you can easily understand what they mean. There's something called as development build. There's something called copy PDB files. So basically, these just means that there are different debugging options. Do you want to use those or not? Do you want to create a VS solution, Visual Studio solution or not? So all those things, and how do you want to compress? So just keep it default. So basically, if you just go here, click on build, then this folder will open up for you. This is the folder where your project is there, right? And I was testing, so I've already created a builds folder, but I can delete that and do it from scratch for you guys. So I'll create a new folder, and we'll call it builds. So remember that this builds, sorry, builds, we can add multiple builds in this. Folder is outside the assets folder that we have. So assets is where we have the actual game and everything. And this is your actual project, complete project. So builds folder is in the same directory as the assets folder and not inside the assets folder. So in the builds folder, I'll again create a new folder, call it desktop. because right now I'm creating for desktop v1, and select this folder, and this is where my project will be built. So this might take a bit of time, but yeah. So once that's done, this folder will open up for you, and this is how the game is compiled and built. All these files are necessary to play the share that zip file to whoever you want to share it with. And then basically if we click open this, we'll see this is how it opens up, and we see that our game is working. So this is how we can do it on desktop. Now let's say I want to share it on the web, and I'll show you exactly how you can actually create a link as well with GitHub. So for that, basically, you'll basically change your platform from desktop to WebGL. So you will basically have this option of WebGL. If this is not activated for you, it will be down here, not after, just after Android. So you go to WebGL. If for some of you who might not already have activated this, it will show up something like this. So this is what you will see. No WebGL module loaded, installed with Unity Hub. So if you click on this, it will install that. And when you come back to this, maybe you might have to restart the project once, basically close it and open it once again. But then you will be able to see this. One thing I missed telling you is whenever is the first time that you add anything from TextMesh Pro, like we added this text, right? Sorry, we added this text from TextMesh Pro, like we are doing this UI and TextMesh Pro. So whenever will be the first time that you do this, a dialog box like this will show up for you, TMP essentials and TMP examples and extras for you to import. So for you to use TextMesh Pro in your project, it is important, it is necessary that you import TMP essentials or it won't work properly. So you have to do this. So the dialog box will show up on its own, and you basically just click on import TMP essentials. Examples and extras is up to you. If you want to do it, you can, but this will show up, the next button will show up once you click on this. So this is something I missed to tell you, but here you go. And now coming back to how we actually build this for the web. So build settings, minimize this. Okay. So now you want to make it for WebGL. So just go to select WebGL, and there's a button here called switch platform. Click on that. It will basically recompile all the code in that for that platform. And then there's one small setting that you'll have to change when building for WebGL. So you go to player settings, and in your publishing settings, the second drop down that you have, it's called compression format. So right now, if you see in mine, it's disabled. Maybe in yours, it might be gzip or brotli broadly, but change it to disabled. So what this does is basically does not compress the files. Generally, a lot of servers are capable of handling compressed files as well. There's some settings that you change in the server, but GitHub pages that the site that I'm about to show you how to host this won't be able to handle that. So basically just make sure to disable this compression. And player settings are a place where you can set up a lot of different things as well. Like if you see, I have company name, product name, version. So these are things that you will set up when you are actually when you actually want to take something to production and actually deploy something. So these are things that we will come back to. And we'll see some of those settings in the future. So for now, just switch to WebGL and then again click on build. I'll create a new folder here. I'll call this folder web underscore version 1. Sorry, version 1, and select folder, and then this will build. In the meantime, we'll go to github.com. I am sure a lot of you already know this, and if not, then please look into what GitHub is and how do you use it. So this is my GitHub page, and let's create a new repository just for uploading it, and we call it Weeps. We are Rollerball for RAB for Rollerball. So we have created a game called Rollerball, and we created this. We are creating this repository to hold this game, as well as I'll upload this game here as well if you want to look at the code later or anything, as well as basically just having this actually up being able to play it on the web. So I can either make it public or private. For now, I'll make it public and I'll share the link with you after this is done. I'll also upload all the codes and everything here, but for now, I'm just uploading this. And then basically I can choose to add a README, all those things if you know good, if you not, then learn these things. This is very important. For now, I will add a git ignore of Unity because I'll be adding the project here. So git ignore is basically a list of, like, it's a template basically which uh, tracks what not to upload to GitHub when you are uploading. I can choose a license, but doesn't really matter right now. So just create this repository. So this is what I have, and this is something that I want to. Now this is where I want to upload my files to. So I'll go to code and I'll basically change this. I want to open this with GitHub Desktop. Generally, I use GitHub Desktop, and this works well. So I just have this. Now my file path is okay. Clone. This just take a second. In the meantime, here in Unity, it's already built me. This thing is built. And if you want to check, I think, okay, you won't be able to play directly from here, but once we upload it, we should be able to play. There's another way that you can check it is basically have this remote server. Let's see if that works. Web server thing that we have. So let's go here. Let's, sorry, I have this builds web. This is where I want. See this, yeah, so this works. So my web project is also working. If I click on reload, scene is reloading. So my game is working on Unity Web as well. So now let's go back to this and close this. Sorry. So now I have this folder. Let me see where it is. So this is where my game is. And I want to upload the whole game there. But most importantly, right now, I just want to upload this file. So let's start with that. And go back to this one. So if you have worked with GitHub pages before, basically there are two ways of making it into GitHub pages can be done. Like a specific repository can be converted to a website. Is either basically you convert the whole root folder of the repository to website, or basically a docs folder. So that is why I'll change the name from this to docs, and that's it. I'll go to my GitHub desktop, init, commit, come back to my GitHub, see. So I have the docs folder has been created and the project is here. So I go to settings. There's this in the settings. There's this thing called pages. I go to pages, and GitHub is disabled. I'll just choose the main branch and not the root folder, the docs folder, and save. So this will now activate the GitHub pages for me, and now I can basically might take some time basically, but not activated yet. So after some time, basically this page would show up, and the way we were able to play game right now in the desktop version, you will be similarly be able to play it here. So I don't know why this is taking some time. Maybe it will take some time and then show up. But just so you know that this works, I created a test repo of the game that we had till now. And let's see if this is working. Go to pages, same thing, done everything here. So this is the game that we had till the last session, till yesterday. Uh, and this is working. So we hopefully that will also soon start working. So right, this is what we had at today's the session of beginning. And yeah, so this is how it will eventually work. Hopefully this will also soon start working. Yeah, so it's working now. It takes a bit of time to basically compile everything, build it, and I guess you also get a mail once it's built. So this is working for me now. Reload, the reset is there, then I can work. This also can be run in full screen. Like if I make this full screen and this runs in full screen. So yeah, that's all. Uh, and basically I'll add the code here and I'll share this link with you guys if you want to ever refer it. Come back here and reference this or whatever. So that's all for today's session from my side. If there are any questions, I am open to questions now.